In this lesson, we're going to learn how we can model different situations with trig functions. So given certain characteristics about a trig function, can we come up with an equation for it and use it to solve problems? So let's start off with what can we do? How can we derive an equation of a trig function if we're given its graph? If we remember, a general equation for a sine curve or a cos curve looks like this. We have an A value, which we know in a sinusoidal graph is also not only represents the vertical stretch or compression, also represents the amplitude. Then we have the type of function, so either sine or we could put cos in here. Then we've got our K value, and we know that from transformations that's going to affect a horizontal compression or a stretch, but in terms of a sinusoidal graph, it also determines the period. The relationship is that the period is equal to 2 pi over k, or divided by k. Then we have our d value, and our d value is the same as what we've always known d value to be, which is a horizontal shift either to the left or to the right. When we're working with periodic graphs, we call that a phase shift. That's another way to talk about horizontal shifts. And our last letter is our C value. We know that that's going to shift our entire function up or down. It's also going to represent the middle of the graph, or the equation of the axis of the curve. So now that we've broken down what the equation of a sinusoidal function is going to look like, we just need to find each of our letters individually and then put it all together into a sinusoidal equation. Remember, this doesn't have to be sine here, this could be cosine as well. Let's start off with the amplitude A. So we know the definition of amplitude is the distance from the middle of the graph to the top, or half of the distance from the maximum to the minimum. So we can see the middle of the graph is at 0 and the maximum is at 0.8, so the amplitude must be 0.8. If we have trouble visualizing what the amplitude is, we can always use the equation max minus min divided by 2. So based on that calculation, we get an amplitude of 0.8, which we predicted from the graph anyways. Now let's find our k value. We know that k affects the period, so if we determine the period, all we have to do is take 2 pi, which is the period of sine or the period of cos before we transform it, and divide it by, take 2 pi and divide it by our period to find k. So what is the period of this function here? Well, we know the period is the length of one cycle. So you can look at this graph and come up with where you think the beginning and the end of a cycle is in lots of different ways. So some students might see, okay, well, if a cycle starts here, it's going to end here. So they see a cycle that way. And other students might say they see a cycle starting here and ending here. That's also true. So what I'm going to do is I'm going to look for one pattern or one cycle in a way where I can easily estimate what the length of that cycle is. So if I were to start it here and end it here, I'm not really given any numbers to go by, so I'm not sure really what the length of that cycle is. But what if I start the cycle here and end all the way over here? Can we approximate that? Well, we can figure out where the cycle starts. It starts at 0.002, and it's going to end at in between 0.006 and 0.008. So it looks like it's going to end at 0.007. So what's the length of that cycle? So the distance between these two, we can just subtract the higher distance from the smaller, or the second x value from the first x value, and the period's got to be 0.005. So now we can find our k value using this relationship here. Now that we know what the period is, that means that k is going to be equal to 2 pi divided by the period. So we can write that out. Our k value is going to equal 2 pi divided by our period, which is 0.005. And that can just be simplified to 400 pi. So now we have our k value. Next, we can find our d value and our c value. I'm going to find the c value because it's going to be the same c value if we choose sine or if we choose cos, just like a and k. A, k, and c are going to remain the same whether we choose to approximate this graph above with a sine curve or a cos curve, but d is going to change. Our phase shift is going to change. So let's find c. C is the equation of the axis of the curve. What is the equation of the line that runs right through the middle? Well, the max is at 0.8 and the min's at negative 0.8. And that means that the line in the middle must be the line of y equals 0. So there hasn't been a vertical shift to this graph at all. If we were to formalize it in an equation, we'd want to find the middle of the graph. And to find the middle of something, we would take the max plus the min and then divide it by 2. So we confirm with calculation that the max minus min divided by 2 is 0. So the equation of the axis of the curve is y equals 0. Therefore, our c value must also be 0. The last letter we're left to find now is our d value. That's our phase shift. There's actually an infinite number of answers to this because this is a repeating graph. So we could say, oh, the graph starts here, so it's shifted over this much. Or we could say, no, the graph starts here and it's shifted over that much. So let's find one example that's going to work here. So taking a look at whether we're going to approximate with sine or with cos, which is easier to approximate in this case? Well, we know that sine starts at the equation of the axis of the curve, reaches its maximum value, and then its minimum value comes back to the axis. So we could see a sine curve starting here. And we know exactly how much it's been shifted over because we're given this point. It's 0.002. If we would instead of try to approximate with a cos curve, maybe we see it starting here and ending here. Cos is going to start at its maximum and end back at its maximum. It's much harder to come up with this value. We can come up with it, but it's a lot harder. So why don't we instead use sine to approximate this graph? So if we use sine, then our d value, or horizontal shift, must be positive 0.002 to make it shift to the right. Now that we have our d value, we have everything that we need in order to make an equation. So we have our a value, our k, our d, and our c. So put it all together in an equation and come back to the video to make sure you got the correct equation. All right, so putting it all together, we have our a value, that's 0.8. Our k value is 400 pi. Our d value is positive 0.002, and when we put it in, it looks negative. And our c value is missing because this graph hasn't been shifted up or down. So try these next two equations on your own. So just remember that all you need to do is you need to find your a value, which is your amplitude, your k value, that's affected by your period, a d value. You can choose a d value that works. Which is our horizontal shift, and there's many that will, and then our c value, which is going to be the equation of the axis of the curve. So try both of these on your own and come back to the video once you want to check your answer. So if you're back at the video, you've tried this question on your own, and we're just going to check our answers together. So the easiest place to start is finding our a value. We know that's just the amplitude, the distance from the middle to the top, or the middle from the bottom. We can also figure out by doing the max minus the min divided by 2, and that's what we did, and you should get an amplitude of 2. That makes sense because later when we find the equation of the axis, or let's just do that now, we know that's the middle of the curve. The middle of the curve is the max plus the min divided by 2, and it's 4. So if the middle's 4, the distance from 4 to 6 is 2. And the distance from 4 to 2 is also 2. So we know our amplitude's right and our equation of the axis is right. And this should actually be a c, not a d. That's our c value. Okay, next is our period. So if it's not clear how long one cycle is, look for a nice clean way we could find more than one cycle. Like for example, you can see that if we highlight this, I may not be able to see how long one cycle is, but I can see how long 1, 2, 3 cycles are because I can see this last cycle ends at 2 pi. So that means 3 cycles are 2 pi. So one cycle would be 2 pi over 3. So if we know that a period, the length of one cycle is 2 pi over 3, we can find our k value by taking 2 pi and dividing it by 2 pi over 3, which will just give us 3. And the last value that we have to find is our d value. So our d value is our phase shift. So for cos, there isn't a shift at all. Cos is supposed to start on the y-axis, and it is starting on the y-axis. So Our coshift we can interpret as d equals 0. And how about our sine? Well, sine, remember, starts along the axis of the curve. So here's the axis of the curve. So here's where we can consider the start of sine. Starting here, coming up, ending here. So how much has this shifted? Well, it's been shifted half of pi. So it's been shifted pi over 2. So when we put all those values together, we can get these two equations. You just need one, but I wanted to show you two. So for this last example again, try it on your own and come back to the video once you think you have it. So if you worked through this already, let's take up our answers together. So our amplitude, when we take our max minus our max is approximately 3.5, our min is negative 1.5 approximately, we get an amplitude of 2.5. Our period is 3 pi plus pi, which is 4 pi. The way I saw it was, I saw this cycle here. So we know that this is the beginning of a cycle and then in a cycle they're ending in the same place, and the patterns are going to repeat after that. This distance from here to here is 3 pi, and this distance is pi. So if we add it together, it makes our total cycle, which is 4 pi in length. Next, we can find our axis of the equation of the curve, or our equation of the axis of the curve, which is going to be our max plus our min divided by 2, and that's going to be 1. So last is our phase shift. This might be slightly more difficult. I'm just going to put a dotted line for our axis so we can better see where our sine curve starts and ends, for example. Okay, so taking a look at cos. So clearly this is a cos curve right here. Let's just highlight this guy here. So the question is, how much has this guy been shifted to the left? Or if let's say that we want to start it here, we could say it was shifted to the right. Let's say that I saw this as my starting point. Let's try to approximate what this x value would be. This is pi and this is 2 pi. So halfway in between, or we're talking negatives, negative pi, negative 2 pi. Halfway in between negative pi and negative 2 pi would be negative 1.5 pi, 1.5. Halfway in between negative 1.5 and negative 2 would be negative 1.75 pi. So we can either write that our d value, if we say that cos starts here, is negative 1.75 pi approximately, or we can leave it as a fraction, whatever you prefer. To find a sine curve now. So maybe you see sine starting here. Again, it has to start on the axis, not the x-axis, but the axis of the curve. So maybe you see it starting here and ending here. That's great. Maybe you see it starting here and going to end off of the screen. That's fine too. What if we chose this part? Is that a sine curve? Well, it is a sine curve, just with a reflection in the x-axis. So if we were to choose this as our d value, how much has this been shifted to the right? Well, again, this is to the left. This would be pi. This is half of a pi. So this would be in between a half pi and a whole pi, which is 3/4 pi. So that could be our d value. If we choose to do this as our d value, by the way, for sine, we need to make sure that our a value is negative so that we make a reflection in the y-axis. So now we're ready to put it all together. So once we put it all together, we could get something like this. And again, if you came up with your own, that's awesome and it's different from this. Just plug one of these guys and your equation into Desmos. Just make sure they match up on top of each other. So for my sine graph, I saw it here. So I made sure that my a value is negative, so that there's a reflection in the x-axis. Our amplitude is 2.5 for both of the sine and cos graphs. Our k value is 1/2 for both. Our c value is 1 because it's been shifted up 1 unit. And our d value for the first guy is negative 3/4 pi, which when you put it into the equation, it's going to look positive. And our d value for our cos graph is negative 7 pi over 4, which again is going to look positive when we put it in there. So now we've tried 3 examples where we've come up with equations of sinusoidal functions given its characteristics. The next step is now to solve problems with these equations.